All right, guys. I hope you guys all had a great day. So today, earlier, we talked a lot about we talked a lot of we talked about diffusion and how we have different types of diffusion, whether that's just passive or active. And again, we know that diffusion all deals with just the movement of substance across the membrane. So earlier, again, we talked about passive transport again, where it does not require energy. We talked a little. But now today, I want to talk about a couple of different things. So let's first take a look at how does um, tonicity change a cell. So it is the ability of a cell to cause the ability of a solution to cause a cell to gain or lose water, and we see this in three main types. Whether that's through uh, whether that's in an isotonic solution, a hypertonic solution, or a hypotonic solution. Now, all these are dealt with in the whole idea of osmosis, which again is the diffusion of water through a selectively permeable membrane. So let's take a look at this first example dealing with isotonic solutions. So whenever this happens, again, the solutions are considered to be isotonic, which means that the it has the same strength. So note here that that strength refers to the amount of solute, not water. Again, it's the amount of solute, not water, inside of the cell. So, in other words, there should be an equal flow of water in and out of the cell with reference to the amount of solute. So in a hypertonic solution, this is when the amount of solute is higher. It, this is when the amount of solute is higher in the outer environment compared to inside of the cell. Because of this, water will flow out of the cell. Again, water sucks everything towards the solute. Remember, water sucks. So, really easy way that I often remember the difference between hyper tonic solutions and hypotonic solutions, and even just this prefix alone is it. Remember the difference between hyper and hypo. So think about whenever you're a little kid and you have a whole bunch of candy around Halloween, like around this time of year. You're oftentimes your energy is above normal. It's a it's above what it normally is on a daily basis. So that's a really good way to remember hyper, because again, your energy is above that normal threshold. Now with hypo, I like to extend that prefix out, so I say hypo, like it almost sounds like I'm on the verge of falling asleep. So that's telling me that is below the normal threshold. So again, in a hypertonic environment has a higher amount of solute in its surroundings compared to inside of the cell itself. So remember those things to help you out with that. Now, whenever we have an animal or plant cell that's in a hypertonic solution, animal cells will often shrivel up and die in a hypertonic solution. And kind of the same thing within plant cells. They'll shrivel up and go through this whole concept called plasmolysis. So going back to isotonic really quick, I know I missed this. Another really good thing to remember if a solution is in an isotonic solution, look at the shape of this. What do you think this looks like? It's something we like to eat in the mornings, especially if you like sugary things. Donuts. So I think it looks like a donut. So if you notice that the cell looks like a donut, and that it again it appears to be full in equal parts in and out of the cell, then that's an isotonic solution. Okay, so now let's take a look at hypotonic solutions. So again, hypotonic solutions are below strength. So again, it's the amount of solute um, the amount of solute is higher inside of the cell compared to outside of the cell. Again, water is rushing towards the amount of solute. So as a result, this is gonna cause again that water to rush into the cell, causing Again, so again, this is going to be where where that solute concentration is higher. So again, summing this all up, in a hypotonic environment, the amount of solute particles is lower than inside. So again, our solute particles are lower here compared to inside, and the amount of water will flow. And as a result, that water will flow into the cell. Again, water suck, solutes suck. So again, solutes suck. Always remember that, no matter which way we're flowing against that concentration gradient. So since water is flowing into the cell, again, it's going to cause our cells to expand, and as a direct result, in animal cells, they may get to the point where so much water is flowing into the cell where it explodes in a hypertonic solution. Whereas in plant cells tend to thrive in this type of environment because of again, think about what those vacuoles do. Uh, um, they help push against that cell wall, providing that rigidity and structure that plants really need. And we talked a lot about that earlier on in this unit. Um, that an important aspect of vacuoles in plants is that they provide that rigidity and structure that helps keep the root up and helps maintain all the weight that the leaves and flowers on a plant normally have. Okay, so pop quiz. So in an isotonic solution, the amount of solute compared to the cell is the same as or equal. Now, what about the amount of water? Is it the same as, lower, or higher? It's the same as, so it's equal. Now, in a hypertonic solution, so remember, hyper, above. So the amount of solute compared to the cell is more solute than the cell, whereas the amount of water that moves should be out of the cell. Again, our hypertonic solution is nice and troubled up. What about in a hypotonic solution? Again, hypo, we're below, we're sleeping. So again, that's going to show us that there's less solute than the cell. Now, what about the amount of water movement? That should be rushing into that cell, causing that cell to burst. So now, really good pages to look at inside of your cell, inside of your book, especially if you need a reference at some point. Look at pages 274 and 275. So let's take a look at active transport now. So again, we talked about how passive transport moves substances in and out of the cell without the use of energy, and it's often going from areas of high concentration or low concentration until a cell reaches equilibrium. This is almost the exact opposite, where active transport uses energy to move substances in and out of the cell, but now we are going from areas of low concentration to areas of higher concentration, and we'll see this in two main ways. Whether that's through the use of protein pumps or through bulk transport. So if you're looking in the book, you're going to want to look at the molecular transport and a bulk transport in the book on page 276. So with protein pumps, again, really the big thing that we need to know here is that again, we're going from areas of low to high concentration against our concentration gradient, but we are using our proteins, which again are those big globular looking molecules that are embedded within our concentration gradient or our cell membrane that allow for that selective permeability of molecules to be carried through the cell, especially if they're very large. That's something we're going to talk about. So if we're looking at this picture, again, all these big guys here are our protein pumps. So with molecules that are higher or bigger than others, this is a great time that we'll use a protein pump, especially if we're talking about like talking about like talking about molecules of sodium and potassium. So there's a really cool protein pump called the sodium potassium pump that is crucial to providing all these essential nutrients that our cells need in in out of a cell to perform daily function. Okay, so let's take a quick look and compare the two. So again, starting off with passive transport, again, we're moving from an area of high concentration to an area of low concentration. So it does not require energy. Now, I want you guys to think like you're rolling a ball down a hill. So in this instance, right now, again, it doesn't require any energy because the second I let go of that ball, we're letting gravity and a lot of different and some other forces do all the work. Now, again, the bulk of our current energy in the form of in the form of potential energy is located right here at the top of our hill right now. But as we let go of the ball, again, all that energy is going to start slowly spreading out and making its way down the hill. But all in all, even if that part kind of tricks you up a little bit, just think again. Whenever I let a ball roll down a hill, it does not require any energy on my part. Now, if I'm looking at active transport, again, we're moving from an area of low to an area of high concentration. This does require energy. So again, now think on the opposite end. Think about how you're rolling a ball up a hill, and we really have to push hard to get that ball up the hill as fast as we can. Um, or we're just using a lot of energy to get that ball all the way up and a lot of work to get that ball all the way up the hill. So within bulk transport, again, the big thing with bulk transport, again, it helps move large molecules or clumps in and out of the cell itself. Now, it does this through two main properties, whether that's endocytosis or it is exocytosis. So with that first one, I want you guys to think back to what we talked about within our um, with, whenever we were talking about organelles and things like that. But just remember that our vesicles act as our car or our transportation organelle that helps move substances around the cell or in and out of the cell. So when you're thinking of endo, think about how you're going into a substance or through a door. So endocytosis, um, this is where we'll use those even bigger molecules and our and a vesicle will engulf it, move it through into the cell. Now, if we're thinking about exo, think about an exodore or going through an exodore to get out of a out of a room or out of a building. This is where again our vesicles are going to transport those larger molecules um, out of the cell through bulk transport. And again, that's called exocytosis. So all in all, the solute concentration outside the cell can cause the cell to gain or lose water. Again, solutes suck. Active transport allows substances to be pumped from lower to high concentrations or for large substances to be moved into and out of the cell, but it all requires energy. Again, active transport requires energy, and we're moving from a low to an area of high concentration. Now let's take a look at how do unicellular, multicellular organisms differ. Now take a step back. What's the difference? What's the main difference between unicellular and multicellular? Uni, remember, means one, so that's one cell, one type of cell. Now with multicellular, again, multi means many. So we have multicellular types of cells in an organism. So unicellular organisms survive with only one type of cell. Um, and that single cell is going to be responsible for maintaining homeostasis, which, if we think back again, that is responsible for maintaining a constant environment compared to its surroundings. Whereas in a multicellular cell, we have a variety of differentiated cells that work together to maintain that homeostasis. So again, differentiated refers to different types of cells. Now, how are cells arranged in multicellular organisms? So, again, it, our cells act as our most basic fundamental unit within cells. So, again, we start off with cells, then we make our way to tissues, then organs, and then organ systems. So, really, with this, if you can find a really good mnemonic device or saying to help you remember that, then that's what I would do. But a really good one that I think might be helpful for you guys to use is the cook took out Sarah's ovaries. The cook took out Sarah's ovaries. So starting off with up here, so we have the cook took out Sarah's ovaries. Yeah, that is a little out of the blue and a little different. So hopefully that might help you remember that a little bit more. Or even if you have something different, take full advantage of whatever works best for you. All right, let's go ahead and get rid of all that real quick. Okay, now how do cells cooperate? So we see this in a variety of different ways, but plant cells have openings in their cells that allow water and solutes to flow between cells. Whereas in animal cells, we have several types of cell junctions, so connections that can either hold cells tightly together or pass molecules between them. And with the use of these specialized receptors, it helps determine how the cell will act when something is passing to it. So collectively, although unicellular organisms work to maintain homeostasis in one cell, multicellular organisms need many cells to communicate through tissues, organs, and organ systems. All right, guys. So I hope this all really answered a lot of your questions and concerns that you may have had about this unit. But if not, we're going to take some time to review over the next couple of days. Again, your test is on Thursday. Test is on Thursday. Um, and, and then we're going to jump into our next unit dealing with ATP, photosynthesis, and cell respiration. But all in all, I hope you guys have a great rest of your day, great rest of your night. And if you have any questions or concerns about this video, please just ask me tomorrow or feel free to email me. Otherwise, have a great night, guys.